So section 3.2, number 90, we're asked to draw a rough sketch of these functions by hand. And it says to do so by looking at the leading coefficient test, finding the zeros of the polynomial and plotting sufficient solution points, and then drawing a continuous and smooth curve through the points. Alright, so if we're going to look at the leading coefficient test, this is an even power. An even power means that either it goes to positive infinity on both the right and left ends, or to negative infinity going to both right and left ends, and it only deals with the fact that whether a coefficient in front is negative or positive. But our coefficient is negative, which means that our function goes to negative infinity at the left and the right. Okay? So as x gets arbitrarily large in either the negative or positive direction, this thing gets arbitrarily large negatively. So our graph has got to look something like this. Okay? Alright. Now, what are our zeros? That's the next thing to look for. Now, this thing, it's not a quadratic, but it is of quadratic type. But there's a negative in front of my leading term. I don't like that. So if I pull a negative out of all of my terms, all of our negatives becomes positives and all of my positives becomes negatives. I can't lose that negative sign because that negative sign is forcing our behavior in terms of going down on both the negative and positive side. So I'm going to get x to the 6th minus 7x cubed minus 8. Now, 8 is 8 times 1 or 4 times 2, but 4 and 2 isn't going to get us to 7. This negative means that one of them is a positive and one of them is a negative. This negative means that the largest one has to be negative, and 8, or minus 8 plus 1 is 7. So I can write this as x to the 6th, I can write as x cubed squared. So we're going to get an x cubed minus 8 and an x cubed plus 1. Now, odd powers play very nice with negatives. Okay, so our 0x cubed minus 8 equals 0. Right, we add 8 to both sides. X cubed is equal to 8. So when I take the cubed root, since this is a positive, it stays positive, so x is equal to 2 is the only 0 we're going to get from there. X cubed plus 1 is 0. Well, we subtract 1 from both sides. X cubed is equal to minus 1. So I take the cubed root. Well, cubes play nice with negative numbers, so x is going to be equal to negative 1, since negative 1 times negative 1 times negative 1 is negative 1. And so our cube plays nicely. So these are our two zeros. We're going to get one at plus 2 and one at negative 1. Plus 2 and negative 1. Oh, 2, negative 1. Clearly not to scale. Okay? And we know that since we're going off to negative infinity, we have to go down through these things. Okay. Now, as far as plotting other points, we don't have many points in between here, and that's really the only interesting things that we have left going on. When x is 0, 0, 0, 8, right? We're up here at 8. We can plot some other points at the halves, right? At around negative a half, we are looking at it. Negative a half, we are at about 7, which means that we're really pretty high up here already, right? We're up at 7. At positive a half, we are at about 9. A little under 8, a little under 9. So we're kind of flat through here. At 1, we are at, well, minus 1 plus 7 plus 8. 7 and 8 is 15 minus 1 is 14, so we're up here at 4, 8, 12, 16. We're up here at about 14, at about 1. At 1.5, we're up a little over 20. 4, 8, 16, 20. So 1.5, we're up here. So we get something that kind of looks like this. It goes flat, and then it gets really big, and then it has to come down through there. Okay. Now, if I was going to do this on a test, I would probably draw my little rough sketch here, and then do an expanded one, right? 1, 2, negative 1, negative 2, and say 5, 10, 15, 20. Okay, we go through at negative 1, 5, 10, we go through 8, we go through 7 at halfway in between, go through about 9 at about halfway there, 5, 10, 15, so we're just under 15 at the 1. 1.5, we're up over 20. And then at 2, we're back through 0. And we know that we have to go down this way, so we have to go up. So it's got to be something like that. Okay. This is certainly a better graph than my rough one, right? Rough test version. Okay. Don't be afraid to do rough drafts. I mean, the idea of getting it perfectly in the first shot is pretty unrealistic. Okay? Check the graph yourself at home. I hope it looks like that. All right. Thank you.